Hey everyone, in this video what we're going to do is figure out what the limit is as x approaches 0 of x cubed divided by tangent of x minus x. Notice that if we were to just let x equal 0, in the numerator we would have 0 and in the denominator we would have tangent of 0 minus 0, which is just equal to 0. So our limit is of indeterminate form 0 over 0. So in order to solve this limit we're going to have to use something called L'Hopital's rule. L'Hopital's rule basically says that if we have a limit as x approaches c of a function f of x divided by another function g of x, this is equal to the limit as x approaches c of the derivative of f of x divided by the derivative of g of x, given that f and g are both differentiable at c and that they're of indeterminate form 0 over 0 or plus or minus infinity over plus or minus infinity. So let's go ahead and apply L'Hopital's rule. So let's go ahead and apply L'Hopital's rule to this limit right here. So we're going to have the limit as x approaches 0 of 3x squared divided by secant squared of x minus 1. We can rewrite secant squared of x minus 1 as tangent squared of x, because if we start from this standard trig identity, cosine squared of x plus sine squared of x equals 1, and if we divide everything by cosine squared of x, we just have 1 plus tangent squared of x is equal to secant squared of x. If we subtract 1 from both sides of this equation, we have tangent squared of x is equal to secant squared of x minus 1. So we have the limit as x approaches 0 of 3x squared divided by tangent squared of x. Now notice that this limit is actually of indeterminate form 0 over 0 again. So we're going to have to apply L'Hopital's rule for a second time in order to evaluate it. So we're going to have the limit as x approaches 0 of 6x divided by 2 times tangent of x times secant squared of x. This is equal to the limit as x approaches 0 of 3x divided by tangent of x multiplied by secant squared of x. All we've done is just divide the 6 by 2 here, and we're left with 3 in the numerator. Now this limit's actually of indeterminate form 0 over 0 again, so we're going to have to apply L'Hopital's rule for a third time in order to evaluate it. Doing so, we have the limit as x approaches 0 of 3 divided by secant to the 4th power of x plus 2 times tangent squared of x times secant squared of x. Now notice that this expression here is just equal to 0 if we plug in x is equal to 0, and this expression here is equal to 1. So that means if we let x tend to 0, we're just left with 3. And that's the final answer to this problem. Thank you very much for watching. I hope you found this content useful. Please make sure to like and subscribe. I hope you have a great day.